The last rule that we're going to look at for trigonometric integrals are when we have both the sine and the cosine function are even and positive powers. Here we're going to use our half-angle identities that you see here, and with these half-angle identities we can rewrite those functions. Now, one of the important things with these half-angle identities to note is that the argument changes from the left to the right-hand side. So here you'll notice that our argument is x. Over on the right-hand side it's double that, it's 2x. So one of the reasons they're called a half-angle identity is what we end up doing is taking 1 minus cosine of 2x all over 2. So here I have twice an angle. Over here on the left-hand side I have half that angle. So that's half-angle identity. So another important thing about the half-angle identities is the entire numerator right here is divided through by 2. The 2 just does not go to part of the numerator, it goes over the entire numerator. So now when we are looking at powers where we have both sine and cosine are positive and even, what we do is we rewrite using these half-angle identities, and then we kind of go back to some of the previous steps that we were working on. The easiest way to show this is to run through a problem, and these are not short problems. You kind of really have to stick with these. So for the example that we're going to look at, let's do sine to the fourth of x cosine squared of x dx. So the first thing important to note, we're looking at everything in terms of squareds here. So sine to the fourth is the same as sine squared, quantity squared, and then of course cosine squared is just cosine squared. And then we can see that I have a sine squared squared times a cosine squared. So what we're going to do is we're going to take sine squared and rewrite it as such. This will be quantity squared. And we'll take cosine squared and rewrite it over here. So rewriting, we end up with 1 minus the cosine of 2x all over 2. And this is quantity squared. And the reason that it's quantity squared is because of this value right here, times cosine squared, but cosine squared can be rewritten as 1 plus cosine of 2x over 2. I think one of the easiest things to do right off the bat is to look at the denominators here. So if we take a look at the denominators, here I'm going to have 2 squared, which is 4. 4 times 2 is 8. We could pull a 1/8 out, and that will kind of make everything a little bit easier. Then we're left with 1 minus the cosine of 2x, quantity squared, so that's going to be 1 minus cosine of 2x, written again, times 1 plus the cosine of 2x dx. And of course we just keep simplifying, using lots of algebra here to rewrite. Now here when we're at this option, order doesn't matter when you multiply, so I could multiply this binomial times the middle binomial, or I can multiply the second and third binomials times each other. But one thing that I note here is that these are being multiplied by conjugates. So if I look at those being multiplied as conjugates, what ends up happening is I have the difference of perfect squares come out of it. So that's what I'm going to do in this step, is I'm going to FOIL these out and rewrite. So when I FOIL those out, I get my first, which would be 1 times 1 is 1. My outside is going to be a plus cosine 2x. My inside will be a minus cosine 2x, and they sum to 0, which is nice because I get rid of a term. And then my last terms will be a negative times a positive, which is a negative. Cosine 2x times cosine 2x I can rewrite as cosine squared of 2x dx, of course. Now, this is nice because now I have a binomial times another binomial. I can FOIL this again, and again this is all rewriting. My first terms will give me a 1. My outsides will give me a minus cosine squared of 2x. My inside will be a minus cosine of 2x. And my last will be a negative times a negative, which is a positive, cosine cubed of 2x dx. Now it's always our hope that something might cancel, but I don't really see that happening here. So let's go ahead and do some rewriting again. Remember, the 1/8 is out front of all of this, and we can talk about distributing through that 1/8 a little bit as well. So let's split this up into separate integrals. The 1/8 integral of 1 dx minus 1/8 integral cosine squared of 2x dx minus 1/8 integral cosine of 2x. And you can already see that some of these are kind of easier than others. 1/8 integral cosine cubed of 2x dx. A couple of these we can integrate pretty easily. This first one comes to mind. The integral of 1/8 dx would be 1/8 x, so we can rewrite that as 1/8 x. And then we're going to have to start dragging some stuff along here. I'm going to move this piece over next. Okay, so I'm going to move this one over. I'm going to integrate it next, and the reason being is it's easier to integrate. U in this case is 2x, du is a 2dx. So I need to multiply by 2 on the inside, compensate with the 1/2 on the outside, and that leaves me with the negative 1/16 integral cosine of u du. So that one will be pretty easy to work with. The next one I'm going to work with, and again I'm kind of moving these around a little bit in terms of level of difficulty. This one will take more than one step to integrate. The other one that we just did, the integral of cosine u, will just be one more step. This integrates, or it doesn't integrate into, but I can rewrite it using my half-angle formula. So the half-angle formula that I want to use is cosine squared of 2x equals 1 plus the cosine of, and this is what I want to talk about real quick. Now remember, with our half-angle formulas, scroll up here, on the left-hand side my angle was half as large as it is on the right-hand side. So moving down here, note my angle is 2x, so over on the right-hand side it has to be twice as large, and you notice that relationship again. On the right-hand side I go 4x, left-hand side is 2x. So I need to rewrite that as 1 plus the cosine of, and this is an important distinction here, we need to make sure that we have that clarified, all over 2 dx. Okay, plus 1/8. Now this is cosine cubed. So with cosine cubed, the rule is to save out a cosine, convert the rest to sine, expand and integrate. Of course that will take a few steps. So let's go ahead and rewrite what we have here. This is equal to 1/8 x minus 1/16. The integral of the cosine of u is the sine of u, and u in this case was 2x. So those are done. These two first integrals are done. Now this next one is a little interesting. This is going to be a minus, I'm going to pull that half out as front as well, minus 1/16 the integral of 1 plus the cosine of 4x dx. Okay, and then here I'll have plus 1/8. Now what was the rule here? Save out a cosine, convert the rest to sine, expand and integrate. So cosine squared will be 1 minus sine squared of 2x, cosine of 2x dx. So what we have here in this first step is we saved out a cosine, we converted this to sine, and then in our next step what we'll do is expand this by distributing this cosine of 2x, and then hopefully we'll be able to integrate that. But we have a little bit more work to do here, dragging along the nice stuff that I already integrated. I have this negative 1/16 integral of 1 dx minus 1/16 integral of the cosine of 4x dx plus 1/8 integral. If we distribute, we get the cosine of 2x minus sine squared 2x cosine of 2x dx. It's getting a little crowded there. Now what ended up happening was I split this up. I distributed the negative 1/16, so I have two separate integrals now. And you can see that this first integral is quite a bit easier to work with than the second. So rewriting again, I have my 1/8 x minus 1/16 sine of 2x that I'm dragging along. Now let's go ahead and integrate this next piece. The integral of negative 1/16 dx will be negative 1/16, keep writing that in the numerator, negative 1/16 x. Okay, now here will be a u substitution. U is 4x, du is 4 dx. So we multiply by a 4 on the inside, compensate with a 1/4 on the outside, and I have a minus 1/64 integral of the cosine of u du. Now for this next one, I'm going to split it up as well. I'm going to have plus 1/8 integral cosine of 2x, which is pretty easy to work with. I think we've already integrated that a little earlier, something similar to it, minus 1/8 integral sine squared 2x cosine 2x dx. Now for our next step on this one, I'm going to let w, instead of using a u substitution because I have a u right over here that I'm already using, I'm going to use w equals 2x, dw is 2 dx then. So you multiply by 2 on the inside, compensate with the 1/2 on the outside, and let's see what we have. And actually I see a couple of things combining. First of all, I have a 1/8 x minus 1/16 x. Well, 1/8 x is the same as 2/16 x. So I should be able to combine these. So 2/16 x minus 1/16 x is 1/16 x. So those combined, minus 1/16 sine of 2x. Now what do we have here? The integral of the cosine of u is the sine of u, but u in this case, if we look right back up here, was 4x. So that's the sine of 4x. Okay, now let's see what we have here. Plus 1/16 integral. This rewrites to the cosine of u du. Cosine of, actually w dw, because we changed how we were going to write that. Minus 1/8. Let's go ahead and rewrite this one as well. We'll use a u again for this. U in this case is sine of 2x. Du is 2 cosine 2x dx, which I have, except for the 2. So I multiply by 2 on the inside, compensate with a 1/2 on the outside. So when I go below to rewrite that, I don't have a negative 1/8, I have a negative 1/16. And I could have written that in a couple steps. But I have a negative 1/16 u squared du. Okay, and rewriting again. Dragging along these pieces because I don't want to forget about them. Okay, so something that we haven't integrated yet. The integral of cosine of w is the sine of w. But w in this case was, looking right up here, 2x. Okay, and continuing on, I have a negative 1/16. Did it again, 1/16 u cubed over 3. So I'll have u cubed over 3 here. I also see something else canceling right here. This negative 1/16 sine 2x and this positive 1/16 sine 2x cancels, sums to 0. So I can get rid of that. Now for this piece, 16 times 3 is 48, and u in this case was the sine of 2x. So this is the sine of 2x quantity cubed. So this is my solution. Of course, I think that we can simplify from here, so let's look at simplification next. In this case, I'd have a least common denominator of 192. So let's go ahead and go through and find that common denominator. I'd have to multiply top and bottom by 3 here, and top and bottom by 4 here. So rewriting, this would equal 12x minus 3 sine of 4x minus sine cubed of 2x all over 192 plus c. So that's my solution. Now, of course, I could check this by taking the derivative. Whoops, and I have that 4 that goes there. So I could check it by taking the derivative. I could also check it in Maple. Maple might not agree with this solution because Maple uses a lot of trig identities to rewrite.